QSO Today, episode 292, Dale Parfitt, W4OP. This episode of QSO Today is sponsored by ICOM America, makers of the finest HF, VHF, and UHF transceivers and accessories for the radio amateur, reminding you that they have just the right rig for contesters, DXers, and rag chewers. And by QRP Labs, makers of the popular QCX kit transceiver and a whole host of parts and kits for the ham radio builder. My thanks to both ICOM America and QRP Labs for sponsoring the QSO Today podcast. We are planning an amateur radio group tour to Israel in May of 2021, a beautiful time of the year to tour and play radio. If you think that you might have an interest in our tour, please click on the banner on this week's show notes page. Welcome to the QSO Today podcast. I'm Eric Guth, 4Z1UG, your host. Dale Parfitt, W4OP, developed a love for frequencies VHF and above, including moonbounce operation, from an early exposure to a 6-meter Gonset Communicator or Gooney Bird. His love for electronics grew into a career as an electronics engineer and entrepreneur, founder of Par Electronics, where custom filters and antennas are his special forte. W4OP tells his story in this QSO Today. W4OP, this is Eric, 4Z1UG. Are you there, Dale?
4Z1UG, W4OP. So nice to hook up with you.
It is indeed, Dale. Thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
You know, I would say I was probably about 10, 11 years old, and I was rather intrigued with radio. I recall we had a Zenith floor model wood radio, popular in the day, but it had shortwave bands on it. And I was just intrigued by all the different shortwave stations that were on back then, many, many more than what we have today. And one in particular was, of course, Radio Moscow, and they had that Moscow mailbag, and which I'm sure they wrote both sides of those letters in Russia, but they just scared the daylights out of me listening to that. And then I had a cousin, considerably older than myself, Bill, later WB2NEV, and Bill was into RC airplanes, and he helped me build my first crystal radio, and it was just magical to me. And from there, I started building an Olson one-transistor radio with a diode detector, and then my father bought me a small Olson portable 3 or 4 tube little portable radio, and then I listening to the amateurs on the air, and we did have an amateur about two blocks over from me. He and his wife were very active, and so I thought about getting licensed. And in Elmira, New York, where I grew up, just a bit south of where Janice grew up, your previous podcast, and but it was adult education. They were offering ham radio, and you had to be 18. So I was 12 at the time, I believe. But my mother was kind enough to enroll, and she was able to take me along and babysit me, so to speak. But at that time, she was finishing her nursing degree at Syracuse and never took the exams. But I did take the novice exam and waited very, very patiently for that glassine envelope. Late 1962, I believe, and I was given the call of WV2, Whiskey Victor 2, Yankee Papa Yankee. And in that day, of course, you had to take a higher class license. Your novice was only good for 1 year. So in about 6 months, I took my general and got WA2YPY, and was at that time very active on HF CW. A little bit of AM, but CW has always been my first love. So that's how it all began, and it continues to this day unabated.
In addition to the help of your mother, did you have any Elmers or mentors that helped you along?
Well, I did. I was remiss. Yes, at night school, we had 2 teachers, Joe Spedico, WB2ZBD, who was a CWOP, and Bill Hamilton, W2HQY, and Bill was a phone op. So they were perfect. Joe taught the code, and Bill taught us the theory. 2 wonderful, wonderful Elmers.
Now, you have your license, you're 12 and a half, 13, so you're actually quite young to be a general class ham, which is cool. How did that play out as a teenager? What was the first rig that you had then after you got your license?
Yes, before I was licensed, my father took me over to an electronics store in Elmira, Chemung Electronics. Chemung is the name of a river that passes through Elmira. And he bought me a National 188 receiver, general coverage receiver, with ham band spread, and I had been saving up for one of the Night Kit regen receivers, and my dad said, we can do better than that. So I already had the receiver. I had done a lot of listening, so I really knew what the protocol was. And then when I got licensed, before my license came, my father bought me a Heathkit DX20, and then when I got my general, I went up to a DX40, so I had a screen grid AM rig, and after that, in ICO, I think it's a 720, the 90-watt CW rig, and later the plate modulator with the Magic Eye tube. And receivers after that, my science teacher sold me very reasonably an SX96, which is a really nice upgrade to the NC188. And after that, just a lot of rigs I can't even recall at this time. So I was very active during high school. And it was at that time, another amateur took me to a ham fest, and he had a Gonset, one of the Gooney boxes in his car on 6 meters. And as we were headed to this ham fest, 6 meters opened, and I was absolutely enthralled by all the really strong signals on 6. And it was pretty much at that time, I was probably about 15 or 16, I fell in love with VHF and up, and don't do a lot of HF work these days except to keep in contact with my other friends, mostly Earth, moonbounce buddies. We use HF for that. But my first love is still VHF and up.
Let's touch on that. When did you start doing moonbounce?
Oh, the year probably about 1990. I was at that time living in West Palm Beach, Florida, working for an antenna company, mostly Citizens Band when I first joined them, Avanti Research and Development. So I was very active in the West Palm Beach Amateur Radio Club. And one of the guys got the idea we might want to try moonbounce. And it just so happened that a ham who I was soon to know, Randy, K9BCT, was moving from 2-meter moonbounce to 432. And he made the club an excellent deal on 4 2-meter Yagis. And we slowly got those set up in an H-array and had, I think, a 300-watt amplifier. And the rig was, or the antenna array was virtually on the ground, so we could manually steer it on the moon. With 4 Yagis, the beam width is not that narrow. You can update it every 15 minutes or so and not lose anything. So that was my first experience. We worked a whole bunch of stations on CW in an ARRL EME contest. But even back then, we're starting to be bothered by household noises, but more particularly computers, computer clocks. And so I talked to Randy, K9BCT, some more. He said, well, I'm going to 1296, and he explained why. And it's just, of all the bands we have, 1296 is probably optimum for EME. It allows the use of large parabolic dishes. Power is relatively easy to come by, even more so now with solid-state devices. And low-noise amplifiers. We're also reaching into the low-noise figures well below a dB. And so if you look at all the different trade-offs of EME, path loss and available power, and 1296 or 23 centimeters is just wonderful. So I put up a dish, and I built a tube amp, water-cooled tube amp, and began to learn an awful lot about feed horns and how to efficiently illuminate dishes. And that was it for me. It's the biggest and best experience I've ever had in ham radio. And in fact, when I had a station big enough where I could hear my own echoes, I must have done that for half an hour. And my station at that time was off the living room, or our family room, and I remember my wife saying at one point, how long is this going to go on for? I said, I don't know. It's so much fun.
I remember speaking to one of the hams who was an early moonbounce operator, that he would actually record his CW transmission on tape and then speed it up and play it over the air in order to get his moonbounce information in before the signal faded. Was there a trick to working moonbounce on CW in the early 90s?
Well, yes, there is, Eric, and it more or less depends on frequency. You can certainly do it on 6 meters and 2 meters and 432. All moon bouncers face a number of issues. One is, of course, the moon is not in a circular orbit. It's an elliptical orbit, so it has apogee when it's furthest from the Earth and perigee when it's closest. And that differential from memory is over 2 dB. So we try to time our operation activity weekends when the moon is at its closest. As you go higher in frequency, you're also hearing more galactic noise. So if the moon happens to be behind a noisy constellation, that will hurt the signal to noise. we also have a problem. It's called libration, and libration fading is a type of QSB, and it's a result of your signal hitting the moon, and sometimes the reflections from all surface of the moon will add up and be louder than what is average, and sometimes it will cancel out. And so it can take a dash, a Morse code dash, and break it up and make it sound like two dots. The higher you go in frequency, the worse libration fading is. So speeding, we mostly run around 13 to 15 words a minute. If we're working big stations, you can speed up to 20 or so, but somewhere around 13 to 15 seems to be optimal on 1296 at least to deal with libration fading. And the last problem is that as a signal transits through the ionosphere, a linear signal can rotate. So if you set up your antenna to be in the same polarity with, say, Europe, by the time it gets through this ionosphere, it can rotate, and it is possible to predict that rotation, but it does vary with time, and that's called Faraday rotation. So if you cannot change the polarity of your station or the other station cannot change his polarity, you can be making a QSO, and all of a sudden you'll be at right angles, and the theoretical penalty for that can be up to 20 dB. So that's called Faraday rotation lockout. Now, in 1296, many, many years ago, before I got involved, we all adopted circular polarity. And I can't tell you the sense right now, but I think we go circular to the moon, and just like a mirror upon reflection, it comes back. So if you go circular clockwise up, it comes anti-clockwise or counterclockwise back. So we never have any of this Faraday rotation. The ways in which we accomplish that circularity have progressed over time, so we have much more efficient feed horns than we used to. So it's just a painless method. And I don't know if other bands, they've tried circular on 10 gigahertz, and there's some problems with that. It doesn't work out nearly as well as it does on 1296. But those are the problems you have in stations that are in that libration level where it can take a dash and break it up into a couple of dots. Sometimes it becomes almost like ESP. And there are a lot of guys doing digital, you mentioned. For me, it's even with before moonbounce on VHF, UHF, it's always been the thrill of being able to work stations that I can hear that I'm not supposed to be able to work or hear. So maybe I'm an old codger, I don't know, but I have zero interest in the digital modes. I just love copying a weak CW and working these very small stations off the moon. In my case, that would be stations maybe with 8-foot dishes and 150 or 200 watts. I can work them very nicely on 1296.
The 3.5 gigahertz band is apparently up for grabs potentially by mobile operators in North America. Have you ever used the 3.5 gigahertz band for moonbounce?
No, I have not. I've listened. I had a dish up for a while on 10 gigahertz before I put my big dish up here, but I've never operated above 1296 as far as transmit. But it's not only 3500. There's now a GPS system in Europe. I believe it's called Galileo, and one of their spectrum is right in the 1296 band. Now, fortunately, they're running circular polarity of the opposite sense that we are, and I have not heard any interference from them. There is a fellow up in New England, and I believe that perhaps his circularity is not all that good, and he has watched his noise level raise on his noise meter and has nailed it down to being interference from this Galileo system. So I hope it doesn't hurt us on 23 centimeters, but as you mentioned, our ham bands, especially the microwave bands, are really under pressure, I think, now.
Is there any conversation happening in your corner of the amateur radio spectrum, say in moonbounce and working outside of the atmosphere, about the constellations of communication satellites that are being put into space by the hundreds in order to create this blanket around the world of internet service?
If there is, I'm not aware of it. It is amazing, though, with all the objects up there, how they avoid hitting one another and causing cross-modulation, intermodulation. It has to be a very well-balanced orchestra, I think, in order to keep that from happening. But to date, I haven't seen anything directly interfering with us from outer space, except perhaps this Galileo project.
And now this message from ICOM America. Get outside and be active with ICOM's new IC705 HF to UHF portable transceiver and its optional multifunction backpack. This is ICOM's perfect solution for SOTA and parks on the air. The ICOM IC705 is your perfect QRP companion with its base station features and functionality at the tips of your fingers in a portable package covering HF 6 meters, 2 meters, and 70 centimeters. This compact rig weighs in at 1 kilogram or 2.2 pounds. This beautiful new rig has RF direct sampling for most of the HF band and IF sampling for frequencies above 25 megahertz, and includes a large 4.3-inch color touchscreen with a live band scope and waterfall display. The ICOM IC705 will be the replacement and amazing 21st century baseband rig for microwave DXers, rovers, and contesters, and the operating choice for those under the new S-HAIL geosynchronous satellite footprint. Unbelievable. The radio is 5 watts with its internal battery and 10 watts with an external 13.8-volt power supply. This full-featured radio operates on single sideband CW, AM, FM, as well as full D-Star functions. Included in this package is a micro USB connector, Bluetooth to support linking to your smartphone or Bluetooth headset, built-in Wi-Fi, integrated GPS with antenna and GPS logger, micro SD card slot, and the HM243 speaker microphone, which is standard equipment. The perfect accessory for the IC705 is the optional backpack, the LC192, with a special compartment for your IC705 with plenty of room for antennas, cables, and other gear to get you on the air from the mountaintop or the local park. There is a link to this amazing new rig on the QSO Today podcast website for this episode, and when you order your new ICOM IC705 from your favorite ham radio dealer, be sure to tell them that you heard about it here on QSO Today. My thanks to ICOM America for their continued support of the QSO Today podcast. And now back to our QSO Today. What is the current rig that you're using to do this kind of operation?
I've been a big fan of Elecraft. Even before they brought out the K2 rig many years ago. I remember standing in line at Dayton when they announced that at 4 days in May with my credit card in hand and my eyes glazed over. I did not know Eric, but I did know Wayne from the earlier work he'd done with the Northern California QRP group and some of his low-power rigs. So I built several K2s in the end, and then when they brought out the K3, I had an ICOM 7700, and I immediately bought the K3 and have never looked back. I think their design philosophy, things that they look at that other manufacturers perhaps don't, and certainly Elecraft was the first one to revive roofing filters, even though Ten-Tec used them. Ten-Tec didn't make a big deal out of it. But I've been an Elecraft fan, and when they brought out the P3 pan adapter, that just makes EME a whole different world to be able to watch these weak signals and tune to them. So it's an Elecraft K3 set up for 2 meters, and then I use a 1296 to 2 meter down converter, transverter. And I've gone through a series of amplifiers. Some are on my website. My current amplifier is a 1 kilowatt solid state amp made by Kuhn Electronics in Germany, and it's mounted right at the dish, so I don't undergo any feed line loss that I would if the amplifier were mounted in the shack. And my current dish is a 13.5-foot accurate surface, but I have on order, it should be here any day, a 15-foot surface. That may not seem like much, but it'll give me about another dB and a half, and that is absolutely huge for EME. So that's the current station.
And do you do any other weak signal modes like meteor scatter or bouncing signals off of airplanes?
Well, I do not. I've worked meteor scatter, especially when I was growing up in Elmira on 6 meters and 2 meters, and I had worked a lot of Aurora. Aurora is a little bit rare here in North Carolina, though I have worked it. But I've got a pretty good system on 6. I've got about 800 watts and a long Yagi, and most days I can hear it's a meteor scatter group up in Ohio and Kentucky, and I think some of the guys are in Indiana, and every morning I can work most of those guys on 6. So big enough stations, you can really do things that people might think odd or can't be done just under regular conditions with no propagation enhancement on 6 and 2 meters. But EME is my first love on VHF right now.
Did ham radio play a part in the choices that you made for your education and career?
Yeah, it sure did. Great question. I knew I wanted to be an electronics engineer from a very, very early age. Didn't know exactly how that was going to be accomplished. My family was not wealthy, but perhaps middle class, and I was a runner in high school, mostly to just kind of calm down the pressures of studies. I was very interested in grades and the courses I was taking, so I started running. And one of the first colleges to make an offer was Army down at West Point, and boy, my dad thought that would be great, and I just wasn't cut out for that. So eventually, Ohio University offered me a scholarship, and I was close to that, and then Syracuse University, just north of where Janice went to school at Cornell, offered me a running scholarship, and that's where I ended up going. And only when I got there did I realize how little I knew about mathematics and electronics. In fact, most of the hams that were in my class up there did not do well. I was just stubborn, I think. But received a fabulous education, pretty much free of charge, and stayed on to do my graduate work there, which was a wonderful experience also. So, yeah, ham radio, the people I met, I knew right off I wanted to be an electronics engineer. And at that time, analog was supreme, and today I tell people I'm an analog engineer trying to survive in a digital world. And I do some digital things, Arduino and that sort of thing, but I'm not nearly as talented as some of the projects I see in QEX and QRP Quarterly. So I'm still an analog guy, I guess.
Well, from what I can see is you're an entrepreneur. You've had a company for many years called Par Electronics. How did you start the business? I'm assuming that you didn't start the business right out of college. You worked for somebody before you actually became an entrepreneur?
Yes. Right out of grad school, I was with Sperry Flight Systems out in Phoenix for a very short time. Had a wonderful boss, but I just, it never really clicked for me. I was there a very, very short period of time and moved to South Florida, where my wife was from, and almost immediately got a job with Avanti Research and Development. As I mentioned early on, they were, at that time, doing mostly citizens band antennas, but very novel antennas, and that's what really attracted me to them. They had a number of antenna patents, and I was with Avanti for many years. But at the same time, I always wanted to do something on my own, and I had filters had always interested me. And I knew at that time there was a problem with 2-meter amateur FM and sideband CW, I suppose, but I mostly heard about it from the FM group that the pagers in the 152 band and the 157, 158 band were causing intermod on 2 meters. And if you work out the third-order intermod equation, you can see why that's true. And so I designed a filter. It was a notch filter with a very asymmetrical design to it. So it put a deep notch on the 152 pagers and then recovered very quickly on 2 meters. And those things just started selling extremely fast. And then the FCC contacted me. It turns out the Marine band was also having problems with the pagers. And they had gotten a hold of one of my ham filters, and it did get rid of the pagers, but had a very high SWR, or return loss, in the Marine band, and that was by design. So I redesigned one for them, and that was a huge product for us for many years. And we've done filter work for varied clients as the military, the Australian tank group, and NASA. Very, very novel stuff, and I have a software package now owned by Agilent called Genesis, and I have the filter mod for that, and it can get you pretty close in design to many filters without having to do a whole bunch of cut and try. Recently, we had an inquiry to make a filter for a vehicle to explode unexploded ordnances in the Middle East, and this company had a much cheaper solution than what was being used, but they had, I think, 9 cameras on board and a telemetry channel, and when telemetry came on, which was yielding GPS and all kinds of temperature, all kinds of data, it would black out the cameras. And so we developed the filter for them. And 2 days later, that filter was in the Middle East. It didn't get tested for a few days, as I recall, because that was right during Ramadan. But they tested it, and it worked perfectly, and we built a whole bunch of those filters. So I've gotten to meet professionally a whole bunch of very, very interesting scientists and engineers that maybe I wouldn't have met. It's just a varied group of people that may not have met if I had stayed with Sperry Flight or something along that line. And then we also got into some antennas some for HF, but mostly VHF and UHF that have some pretty novel characteristics compared to what was already in the marketplace.
So for power electronics, would you say it's your filter product line, which is the most important products that you sell now?
It is to me. It's because some of the clients we have are pretty darn demanding, and I learn through them, and it's very, very satisfying to come up with successful products. Recently we make a line of VHF and UHF horizontal omni antennas, which are unique in that they're better, much better pattern than the halos and squalos and those type things you see. And in addition, they do not radiate from the mast or from the coax, what we call common mode radiation. And I was building many of these things, hundreds and hundreds for the RFID industry at 433 megahertz. And one client in particular in upstate New York was really putting us to a test to see how many we could build. And we both agreed that at some point when I couldn't meet their demands, I would sell the design to them. And that occurred about 2 years ago. They came down and saw what I was doing, and then I met them up in upstate New York a year ago, September, and we started doing a design for manufacture, and that product is now being built by the thousands over in China. And that was an illuminating experience for me too, because not having been in a large company that did that sort of thing, I learned a lot of procedures of how something goes from concept into a working model, and then finally, perhaps the most important, the design for manufacture, where this thing has to be able to be repeatedly manufactured, cost-cutting, and that sort of thing. So the filters definitely dominate. And
working perfectly each time, right?
That's exactly right. In fact, there was one interesting problem once they started manufacturing. This is kind of a rabbit trail, but I got a harried call from upstate New York, and they said these antennas, some of them were having a high failure rate in production. They cannot tune them. And that it just seemed odd, so they sent me one that did tune and two that did not tune, and it really threw me for a loop. And they're pretty easy to tune. Requires an Allen head a set screw, and you move rods in and out. And I just couldn't get anything to repeat. And I finally looked at their rods, and I thought, it just doesn't look right. And I put an ohmmeter on the rods. There was no continuity. For some reason, China had decided that anodized aluminum would be better, passivate the surface. Well, they didn't know, I guess, anodizing is an insulation surface, and so there was no electrical contact. So I put one in the lathe and turned that surface off, put two rods in the lathe, two per antenna, and then everything worked perfectly again. So that was kind of a hiccup that I never, ever would have imagined could happen.
But you had the expertise to be able to solve the problem. I saw on your website, and I think maybe you've mentioned them, but you have what are called omni-angle antennas on HF. What are omni-angle antennas, and how are they different from the antennas that we currently see or we normally see in amateur installations?
Yes, well, the omni-angle design is really VHF, 50 megahertz and up. We do have an HF version called the rectangle, which isn't a particularly great omni as the omni-angles are, but I wanted to operate mobile, and all you saw in the marketplace were halos and squalos, which are half-wave dipoles bent into a square or a circle, and when you do that, it also lowers the frequency. So it's a little bit shorter than a half-wave dipole. But when I modeled halos and squalos, the pattern was not a circle at all. I mean, you'd like an omnidirectional pattern, so when you turn a corner, or if you're using them on a tower for net control, you don't want to have areas north, east, south, west, whatever, where you have nulls or dips in the pattern. So I recalled an application note, I think it was RCA, that I'd researched many years before, and it was kind of an oddity back then because it was before modeling, but it was an antenna that was longer than a half wave, and it was shaped as an isosceles triangle. And it just happens that when you make that isosceles triangle of the right angles and the right length, the current distribution is such you can yield, in theory, a perfect omni, certainly better than a tenth of a dB being an omni, whereas the halos and squalos were kind of an elliptical pattern, about 6 dB out of omni. So when I saw that, I thought this is really unique, but the problem was matching it. whereas the halos and squalos are easily matched to 50 ohms. The omni-angle is not. It's about 10 ohms resistive and, from memory, about 90 ohms or 100 ohms inductive, and that's because it's longer than a half-wave dipole. But it takes that length and that shape to make the omni pattern. So I did work out a high voltage and high current matchbox for it, and also included a balun, because just like a dipole, if you don't have a balun in there, now the feed line is part of your antenna. And if you're trying to achieve a nice omni pattern, the last thing you want is radiation from the coax screwing that thing up. The last feature then is to isolate the antenna from the mast so the mast isn't radiating. And that is a problem that the halos and squalos do face, and that is feed line radiation and mast radiation and the less than perfect omni pattern. So as I was talking about earlier, the antenna that is now being built in China, that uses our omni-angle design. And then we still have the 6 meter, 2 meter, 222 megahertz, and 70 centimeter versions that we sell to the amateur community, either single antennas or stacked antennas to achieve more gain.
Now, you say these antennas are mobile antennas, although they look actually like base station antennas. Are there mounts, or do you also make mounts that you could actually run these antennas down the highway while you're using them?
Well, we do not make mounts, and I would just, to put a number on it, say perhaps 10% of our users are mobile users. A lot of rovers, it turns out, in fact, and they have, these rovers. It's incredible the arrays they're able to keep on their vehicles as they're driving. So I don't try to impinge on what they're going to do already for their mounts, and I don't recall anyone ever having one blown off. The 6 meter is a isosceles triangle whose base is 42 inches and the sides are approximately 46 inches. So it's not a small antenna, but it's less wieldy than the bug catchers and things you see guys driving around with. Some do use them mobile, well in motion. Others will park as rovers and get everything set up, and they raise the mobile towers or masts up when they're fixed mobile. But about 90% of our users are guys maybe getting on 6 or 2 for the first time. They don't want to get into the money of a Yagi and the complexity of a rotor, so they might put up a single omni-angle, and then as they get more serious about it, they might stack 2 of them. That gives you almost 3 dB gain on receive and transmit, or stack 4. I have a friend out west with a stack of 8 of them on 6 meters, and he tells me he's doing killer stuff in the contest without having to rotate his long Yagi in different directions looking for stations.
Let me take a quick break here to tell you about my favorite amateur radio audio podcast, the Ham Radio Workbench Podcast with George, KG6VU, and Jeremy, KF7IJZ, where they pursue topics, technology, and projects on their ham radio workbenches every 2 weeks. George and Jeremy document their projects and make circuit boards available for sale to their listeners. They have interesting guests and go in deep. Even if you're a seasoned ham radio builder or just getting started, be sure to join George and Jeremy for the Ham Radio Workbench podcast. Use the link on this week's show notes page by clicking on the image. And now back to our QSO Today. Now, we have some listeners who live full-time in mobile homes. Would the rectangle antenna for HF, maybe like for 20 meters, could that antenna be mounted on top of a mobile home and maybe lifted above the top of the mobile home for operation and then hoisted back down? How far above the ground do those antennas have to be before they operate well? Do they have to be like a quarter wavelength or half wavelength above the ground?
Well, that's a good question. With any horizontal yes, as with any horizontal antenna, if you're interested in DX, the rule of thumb would be about a half wavelength, where you start getting some elevation lobes that are at a low angle, so you can work F2 layer propagation. As you start to bring any horizontally polarized antenna closer to the ground, the elevation angle of the main lobe goes higher and higher until you have what we call cloud burners or NVIS antennas. So the rule of thumb is a half wavelength above ground, but certainly I've worked a lot of DX with when hiking, with the antennas a lot lower than that. But that's the rule of thumb is a half wavelength above ground. They're relatively lightweight. The rectangles are 8 feet by approximately 4 feet rectangles, and they weigh maybe 2.5 pounds or so. So you can really buy one frame and then buy different matchboxes for it. So you could have your 20-meter rectangle, take it down, and take off the 20-meter matchbox and put on a 17 or 15 or 12 or 10-meter matchbox and be on that band. None of our antennas require tuners. They have a inherently low SWR once you tune it. Now, on the 20-meter rectangle, because it's such a small antenna, you would normally tune it optimally for the CW portion or the sideband portion. And if you tune it in between, then it may have a 2.5 or 3-to-1 Biswar band edges, and you could then use your shack tuner to help lower the SWR. But in general, the omni angles or the rectangles, or when I was manufacturing the NFEDs, none of those antennas required a tuner.
This rectangular antenna is not a full-wave loop. It's like a dipole that's folded into a rectangle?
Yes, perfect. That's exactly what it is. They're half-wave dipoles that are shortened by center loading, and a beta match, which is another inductor inside the matchbox to raise the feed point up to 50 ohms. So they have in general an omni pattern. It's not like the omni angles, but they are just really shortened dipoles.
Just to shift gears for a second, you obviously through Power Electronics demonstrate considerable technical expertise. Do you think the schools and maybe the amateur radio community is producing the kind of technical expertise that you might need in your company in the future to continue to provide the value to your customers that you do now?
Well, it's probably a good question. I think the emphasis today, and rightly so, I suppose, is on digital electronics. RF engineers seem to be few and far between. I do get calls from RF engineers, but they're mostly older people, and they've sometimes retired and gone back to work for a company because the company did not have any talent in electromagnetics. So it's kind of hard to say. I think a person could be trained fairly quickly if they, are adept with electromagnetics. I know when the first PCs came out that were getting up in clock speed, as the traces on the PC board were now looking like transmission lines. They were not 50 ohm, and you'd send a clock pulse down a PC board trace, and because the match at the far end of that trace was not a good impedance match, you'd start to get reflections, so one pulse becomes 2 or 3 pulses. So the computer industry then had to start employing RF engineers to figure out. Again, I think the emphasis is on digital electronics, but if a fellow goes through electronics engineering, I think they've got the math background, particularly calculus with Fourier series, Maclaurin series, that sort of thing, that they can catch on to what's going on. And also today we have some wonderful simulator tools that can catch you up to speed pretty quickly and catch gross errors that might otherwise go unnoticed and take a fair amount of R&D to figure out what's wrong here. So computer simulators have played a big part in taking digital guys into the RF field.
Have you had much thought or thinking about how to attract maybe younger people, younger hams into the hobby?
Well, I am a member of a group over here. We're in the mountains of western North Carolina, and you can drive away sometimes and not even see a house. But we do have a group over in Silva, and I'm a member of that group, and I've done a lot of talks to them on moonbounce, antennas, vintage equipment. All these things are my passion. So, and we have 3 or 4 hams within maybe a 10-mile radius of me, and I do quite a bit of work for them, and they sometimes want to drop something off here and have me work on it or build it or whatever, and I say, no, you're going to stay here and watch and see how this is done. So I think, Elmering is not lost. I think maybe it was more important when I was a kid growing up. At least I just had so much respect, and I was so thankful to have the Elmers I did. But I think Elmering in amateur radio is not what it used to be, but it still can be that's what some of the older hams have to offer.
Okay, so one of the reasons that we may be hearing some sputtering and fluttering on our telephone conversation is I'm actually dialing a landline through Skype, but I think that probably, you say you're in a rural area of North Carolina. What is the service that you have out there? Do you have twisted pair telephone service out there, or are you on some kind of a link?
Yeah, this is all wired road around the lake here. I have not gotten to that yet. I don't know how far the fiber extends, but I'm just on a wired telephone here, and my internet link is a high-speed ADSL.
Oh, is that right? Okay. I noticed on your QRZ page that you have a receiver that's called a PR8. And frankly, I don't think I've ever seen a PR8 receiver in the marketplace. What is a PR8 receiver?
Yeah, that's Papa Radio 8, PR8. And I love restoring old equipment and documenting it before it's lost, but I also like building my own gear. And the PR8 was a design by Wes Hayward, and I can't recall the other amateur. I think he was a K5. It appeared in QST. It was called a progressive receiver, and that's where the PR came from. And the design I built was an 8-band receiver. So you could start out with just an 80-meter receiver in the PR8, and then you could add converters to it, very much like the Drake 2B was, an 80-meter receiver with crystal-controlled converters for the other bands. And then this goes back a ways when I built that, but I added to that some homebrew filters for AM, sideband, and CW, and I added a notch filter to it, selectable AGCs, tone control, which is really nice when you're listening to shortwave or broadcast AM stations. And I really can't think of what else I added in there. But it really became a beautiful receiver, very, very stable. I worked a long time on the VFO on that thing to make it stable. It's just an analog VFO.
But it has a beautiful...
Because I designed my own crystal filters for it, I was able...
Dale, it has a beautiful glass front panel that's painted and stuff. Was that something of your design, and do you have some kind of a pointer that goes behind the glass that moves up and down the band?
Yeah, that dial is, I'm going to say it's an Eddystone 890. I'm not sure of that number these days, but Eddystone was, and I think still is, a major receiver manufacturer in Great Britain. And they sold that dial. It was also used on the Clegg Venus 6-meter sideband transceiver, and also the Clegg Zeus transmitter and the Interceptor receiver. And I can't think right off, but I'm sure some other amateur manufacturers here in the States use that dial. So that's really where I started. I found one of those dials. It has a flyweight on it, and it's a beautiful tuning slide rule dial. And I fooled around with making my own cabinet, and even though I've got a full machine shop, it just wasn't looking good. And then I found a Carcass Heathkit SB313 cabinet, and that was just the perfect size. So I made my own front panel for it, and the lettering is done with water slip decals and many, many clear coats of auto clear acrylic. So you put the decal on, you spray a clear coat of the clear enamel on, and then you'll see the edges of the decals. So you carefully wet sand that, spray it again, wet sand, spray it again until they all disappear. And it's really sharp graphics, much better than silk screening, I think. And that was the housing for the cabinet, and the matching speaker, which is probably on my website, was the matching speaker for the Heathkit SB303 receiver, just redone in the colors and grill cloth that I wanted. And that was about a year-long project. It was a learning experience for me. I added the S-meter also. That was another addition to it. And that year I entered that at 4 Days in May, which is the QRP group that meets at Dayton every year. They have a home brew contest, and I entered that, and gosh, it was just the big-time winner. It was wonderful.
Well, I've only been to Dayton once, and the 4 Days in May was my go-to place for the time that I went. So I highly recommend 4 Days in May, the day before the Dayton Hamvention opens for anyone going. What was the most complex homebrew project that you've completed on your bench? It's
a 160 through 10 meter and perhaps 6 meters. I still haven't completed the PA that I'm happy with, but that's up there also. And that was also at 4 Days in May and the homebrew contest, and also won that year. It's a pretty complex receiver. Today you could do it with a lot less stuff, but it's a 9 megahertz IF board in it, and it has separate bandpass filters for the receiver, low-pass filters for the transmitter. It has a hang AGC on it, in addition to fast and slow AGC. Of course, a different bandwidth for CW and sideband, calibrated S-meter, and about a 12-watt PA in it. Very, very fun rig. I spent a lot of time on that, and I'm still not done with it. I don't think I ever will be. I bought more 9 megahertz crystals to redesign the filters in that rig. But boy, it looks beautiful, and I did add some digital electronics to it, so you could select memories on the VFO and change bands and that sort of thing. There's probably better and more complex receivers out there, but for me, as busy as I am and and not really a digital guy. That was the most difficult project that I've ever tried.
And now this message from QRP Labs. QRP Labs has shipped thousands of QCX QRP transceivers kits to date. The odds of working another QCX user gets better every day. If you're looking for a satisfying kit experience where you end up with an amazing performing QRP transceiver for under $50, let me say that again, for under $50, then you owe it to yourself to go to QRP Labs. We have many home brewers who listen to the QSO Today podcast. For you, QRP Labs also has parts, filters, enclosures, and other handy devices to make your home brewing experience even better. You can use these parts to either enhance your QRP Labs kits or to beef up your own homebrew designs. Be sure to browse Hand's entire website. Use the link on this week's show notes page or the one in the sponsored section of the QSO Today website to get to QRP Labs to buy your QCX or any of the other fine QRP Labs kits or parts. QRP Labs is my go-to ham radio kit company. It should be yours too. QRP Labs. And now back to our QSO Today. What's your favorite piece of test equipment on your bench?
Without a doubt, that is the Agilent 8713 vector network analyzer. I've got another piece that was given to me by a ham friend from my Avanti days. He repped a line of test equipment, and one of them was a French manufacturer, Adret, A-D-R-E-T, and he sent me one of their synthesized signal generators, and I've just used that so much. Because it's calibrated in, you pick the units, microvolts or dBm, dB microvolts, whatever. And for aligning receivers and a lot of the older rigs I restore, that's just been absolutely fabulous. I use that more in the amateur work. Of course, the vector network analyzer sees an awful lot of use with filters because it allows me to tune the filter and look at what we call the S21 parameter, the gain of the filter, over frequency spread, and also S11 or the return loss or SWR simultaneously. And that's important because the filter has two important characteristics, that its response is what you want, but it also has to have a good return loss or SWR. So that's more commercial. But so I guess as far as the ham work goes, it's that wonderful Adret signal generator.
What kind of impact has amateur radio had on your family life?
Well, my wife did get licensed. She's not active at all, but renewed her license. She did get licensed, I think, just to prove she could do it because she had to pass the code exam also. She's a very, very, very talented registered nurse. I mentioned that when I was taking night school in amateur radio, my mother babysat me, but she was tied up with her own studies at the time and never took the test. And then when I was working for Avanti down in Florida, and this goes back in probably the mid-'80s, she called me on the phone one day and said, get on forte CW. Here's my call. So, this is probably, 20 years? 15, 20 years after I'd become licensed. It had to be 20 years. She had gotten her novice license, WN2UNU, and she, too, just loved CW. And we had a station at Avanti, a Drake B line and a Heathkit amplifier, had some big Yaggies up and some big antennas, and we would work every lunch hour on CW. And then she got her general ticket, and we would work on single sideband on 20 meters. So the fact my mom got licensed really touched me, and then she went ahead and got her advanced license, so then I had to go get my extra class license just to keep up with her. And that early cousin I told you about, he became, Bill Parfitt, he became WB2 NEV, and then his son, Billy, who is 3 years older than me, is still today WB2 GJV. And I had another cousin, Vern, and he was WV2VKN. So we've had a lot of hams in the family, and I think my wife she went to field day with me one year. She's not at all a electronically technical person, but she shares a lot of the things I share, and it's been a joy for us, I think, except for maybe this big giant parabolic dish antenna down over the hillside. We've had some discussions about it, and the fact it's going to get bigger here in about 3 months, but that's for another time, Eric.
Well, I think if you look at the picture of it on your QRZ page, that antenna pretty much blends into the hillside. Perhaps maybe the new antenna won't as much, but I think that grid kind of antenna seems to kind of blend in. What do you think the greatest challenge is facing amateur radio now, from your perspective?
You know, looking back on it, I hope that today's amateurs don't forget our past. You hear a lot of new hams on the air today, and they do not know the protocol at all. And some, we've got a group of EME guys that get on 80 meters sometimes at night, and guys will break in. We're down in the extra portion of the band, and they've got a general class ticket. They don't know where the band edges are. So I think if they did a lot more listening, and again, this is from a cranky old guy, but if they did a lot more listening and developed the lingo, instead of the word balun, B-A-L-U-N today, balanced to unbalanced, I hear a term balum, B-A-L-U-M, which I am told comes from the CB group, Citizens Band Group. And there's just a lack of desire, it seems, to learn the technical end of it, to build things, and a lot of the emphasis today is on talking, and that's fine. I would just like to see the history of amateur radio, the older equipment more appreciated, and for amateurs today to become more technical before that is just lost, and it turns into more of just people getting on the air and talking, but not being able to build their own antennas, not being able to even design their own equipment. That is not impossible today. You can really build some nice gear yourself. Even if you're not designing, you can copy another design. So I worry about the lack of the technical end of amateur radio today.
Do you have any thoughts on how amateur radio clubs might make their new hams more technical? I mean, is there something proactive that amateur radio clubs can do?
Well, I think getting people in to speak on these subjects, it's interesting you should ask that, because several weeks ago I was on and I saw a 6-meter regenerative transceiver, much like the Heathkit 6ers and 2ers and lunch boxes. And I really had a passion to try to preserve some of this information. And so I bought that rig, and on the back of it, lo and behold, was the builder's name and email. But I knew the guy that sold it to me bought estate sales. And I looked up, and sure enough, this guy was a silent key. And I wanted to learn more about this radio. And I did find his club, and his club put me on to his 2 sons who were hams. And they told me the story behind this radio, that it was done as a club project. And their design pretty much came from an article in QST, which was entitled The Club Saver 2-meter rig. And this club was just foundering, and they decided to do a home-built project. They built about 50 of these transceivers. They put a top price on it. It would be $30. This is back in 1957. But that really saved their club, and I think enhanced the club that built the 6-meter version of it, redesigned it, and built it for 6 meters. So I think club projects, whether it's building 2-meter Yagis or perhaps some Arduino project, I think building really helps with these clubs. And if you can have good speakers in, I know there's a club over in Raleigh, North Carolina, and they have terrific speakers. I am not a public speaker, but I kind of enjoy it more and more. So I've done more clubs in the last probably 10 years than I did when I was in Florida when I just spoke to our club. So I think speakers, and if you can get these people involved technically, have a building night. Everybody's is busy. I recognize that. But those are my 2 thoughts on it. Really, really speakers that can capture your imagination, and then get a club building project.
Well, I think we're almost at the point, or maybe we're beyond the point, where it's even possible to bring your speakers in on Skype or something like that, for example, if the club has access to a pretty good internet connection and maybe a couple of projectors so that you can see your speaker and their slides. So therefore, your club, even if it's rural, might have the opportunity to bring in some pretty high-power speakers. Well,
I couldn't agree more, and I wish I knew the group I spoke to in Atlanta a year ago, September. The club was active, but one of the fellows down there, and I knew him because he's very much involved in 4 Days in May, especially in the early days. His name is Jim, and his call, hope I've got it right, is W4QO. And so their club has kind of reinvented itself, and they put on this series of seminars in the fall. It's free to get in. You can buy raffle tickets on some beautiful equipment they have to raffle. But every year they get in 3 speakers. And that year, the first speaker was a ham who had done a de-expedition on a very, I'll call it a delicate island in the Pacific, where they had to haul everything out, bathrooms, everything. They could touch nothing. And it was a really neat, and a number of QSOs they made from that island. And then I went next and did my talk on EME. And then the last speaker came in via Skype, and I can't remember her. It seems like it's Judy, but anyway, she's very well known. She's a self-taught engineer, has done some major projects, and so she was brought in on Skype. And every year, this club down there gets bigger and bigger. They take these funds and they award scholarships for students that are interested in engineering and science. And that, just like that club that was revitalized and reinvented by making those 2-meter transceivers, this group down there, and I wish I had the name of it. I can get it to you, Eric. Gosh, it just gets bigger and bigger. The crowds are huge down there. It costs you nothing to get in. You just buy raffle tickets.
What advice would you give to new returning hams to the hobby?
Well, don't be shocked at all the changes. I have phone calls and emails from amateurs all the time that they got a license early on, but family and their careers took them away from it. Now they're getting back into it. And many, I meet them because they want to get on 6 meters or 2 meters, something like that. And so it's kind of fun to talk to them and hear what equipment they're using back then, and then maybe get my thoughts on what they should be buying today and that sort of thing. So it's a learning curve, isn't it? Because now we have all these digital modes in addition to sideband and CW and AM, and some of the hams that are getting back into the hobby, they still want to be on AM, and there is a place for them, either with the newer rigs like the Elecraft rigs or the 7300 ICOM, which sound very good on AM. And fortunately, that's one good thing about amateur radio. There's something for everybody in amateur radio, and all of them seem to be excited about being back into the hobby. But they did what they had to do with their family and career. And so I think it's fun for them, and they seem to be embracing what there is today.
Well, Dale, you've been a wonderful guest. I really appreciate your joining me on the QSO Today podcast. With that, I want to thank you and wish you 73.
73, Eric. I've really enjoyed this, too, and thank you for having me as a guest.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Dale. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in W4OP in the search box at the top of the page. My thanks to both ICOM America and QRP Labs for their support of the QSO Today podcast. Please show your support of these fine sponsors by clicking on their links in the show notes pages, or when you make your purchases, that you say that you heard it here on QSO Today. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the other episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes page. I am grateful for any way that you show appreciation and support. It makes a big difference. QSO Today is now available on iHeartRadio, Spotify, Libsyn, and TuneIn, as well as the iTunes Store. If you own an Amazon Echo, you can say, "Alicia, play the QSO Today podcast from TuneIn." I still use Stitcher to listen to podcasts on my smartphone. The links to all of these services are on the show notes pages on the right side. Until next time, this is Eric for Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.